Okay, in this video, I'd like to pick up where I left off while working through the Math Excel practice test. Here at number 10, I'm asking you to use a sum or difference formula to find the exact value of the trigonometric function. Now, this would be a good no calculator question. And the reason for that is because, well, the final answer doesn't require a decimal result whatsoever. Now, the interesting thing here is that the instructions say use the sum or difference formula. And so it doesn't matter which one you use, whether it's the sum formula for cosine or the difference formula for cosine. They both will generate the same and correct final answer. So I'm looking at this 105-degree number, and I see that as cosine of 45 degrees plus 60 degrees. In my mind, 45 plus 60 is 105. So I'm going to go with a sum identity. Certainly, you could use a difference identity as well. If your brain went to 135 degrees minus 30 degrees, for example, that would work too. And the only restriction or only comment that I'll add to this is that the two numbers that you choose, since this would be a no calculator question, the two numbers that you choose inside of your grouping symbol should be numbers that are already found on the unit circle that we memorized. This wouldn't benefit us in this case choosing some other angle measures that are not in the unit circle because we would need a calculator to evaluate them. So again, I'm going to use this first one. I think that's the one that came to mind initially, so that's the one I'll run with. Now, if you've forgotten your sum or difference identities, make sure you go back to the handout on day 53, 54. That's when we got into our sum and difference rules. And here we go for cosine. The sum identity for cosine is cosine alpha times cosine beta minus sine alpha times sine beta. So back to here, we'll go with cosine 45 times cosine 60 minus sine 45 times sine 60. That's the way the identity was described. And here again, using our knowledge of the unit circle, we should be able to evaluate these without too much effort. The x value at 45 degrees is radical 2 over 2. The x value at 60 degrees is 1/2. The y value at 45 degrees is radical 2 over 2, and the y value at 60 degrees is radical 3 over 2. We can multiply these groups. So within this first group, we get radical 2 over 4. In the second group, we get radical 6 over 4. And since these two fractions have a common denominator, we can subtract them. Radical 2 minus radical 6 divided by 4. Now that's the answer that I would provide, and I would venture to say that by entering that into Math Excel, it will accept that as a result. You'll notice that the solution in my answer key looks like this, but it is equivalent whether we have a group that's being divided by 4 or a group that's being multiplied by 1/4, the results are the same. And whether we write square root of 2 minus 6 or negative square root 6 plus square root 2 makes no difference. Addition is commutative. So as long as your math is correct and you obtain a correct answer here, even in this fractional form, then I know that it will be accepted in Math Excel. If you end up getting a note saying that your answer is incorrect, then that means you did do something incorrectly back here. Math Excel's analytical engine or its scoring engine is capable of determining different formats of identical answers. Just be careful and make sure that your work leading up to that is correct. With this example here, whoops, sorry, as I was saying, with this example here, my mind went to a subtraction, and I saw this as tangent of 60 degrees minus 45 degrees, and that's how I obtain 15 degrees. So I'm using the difference formula for tangent here, tangent alpha minus tangent beta divided by 1 plus tangent alpha times tangent beta. Now the tangent value at 60 degrees is the y-coordinate divided by the x-coordinate. So that y-coordinate is radical 3 over 2 divided by the x-coordinate of 1/2. Radical 3 over 2 divided by 1 over 2. Well, these twos both in the denominator cancel, and we're left with just radical 3. So tangent of 60 degrees is radical 3. Tangent of 45, the y divided by x in this position, is 1. And then we have 1 plus radical 3 times 1 in the denominator. And here again, radical 3 minus 1 over 1 plus radical 3 is a fine answer. That's what I would go with. However, if you use the tools in Math Excel to guide you through this, they'll go through the trouble of rationalizing the denominator. And again, I would argue that if your math was done correctly up to this point, Math Excel will accept this answer. In problem 12, the question looks a bit challenging at first, but it really is just another application of our sum or difference identities. Here we have sine of some alpha times cosine of some beta angle plus cosine of the alpha angle times sine of the beta angle. Both alpha and beta are the same in both groups. So as long as we can recognize the pattern that's been established here, then we could simplify this pretty easily. Now the identities that use sine times cosine are here, the sum for sine or the difference identity for sine. And when there is a plus sign in between, we know that this is the sum identity for sine. When there's a minus sign in between, we know this is a subtraction or difference identity for sine. So we do have the plus symbol in between, so I know that this is the sum identity for sine, and it's going to look like alpha plus beta. Now I don't need A and B or alpha and beta here. I know what those numbers are. Alpha is 75, beta is 15, and 75 and 15 is 90. So this whole expression that we started with on the left, this entire component here, is really just the same as sine of 90 degrees. And well, that's easy. At 90 degrees, the y-coordinate is equal to 1. So I know that this whole expression is really just equal to 1. In this example down here, we have cosine times cosine, sine times sine. So that's our sum or difference identity for cosine. Again, I'm looking at the notes from day 53, 54. And here we are, only this time when there's a subtraction sign in between the grouping, that indicated the sum identity. When there's an addition sign in between, that indicated our difference identity. So there is a difference or a subtraction in between. We're talking about the sum identity for cosine. And alpha in this case is 50, beta in this case is 10. So 50 and 10 is, of course, 60, and the x value at 60 degrees is equal to 1/2. So we know this whole expression here is really just the same or equal to 1/2. For number 14, clearly we're dealing with a bunch of tangents, so this is the sum or difference identity for tangent. With the plus sign at the top and the minus sign at the bottom, this is the sum identity for tangent. So we're talking about tangent of 20 plus 10, which is 30. And at 30 degrees, the y-coordinate is 1/2. The x-coordinate is radical 3 over 2. And again, with these 2's both in the denominator being divided, those will cancel. And tangent of 30 degrees is 1 divided by radical 3. That's an acceptable answer, even though Math Excel will lead you to an answer that has a rationalized denominator. I have seen this one accepted in the past, so I'm certain it will work for you. I think that's a good place to stop this video. It's been 10 minutes. I'll pick up starting with question number 15 in the next one.